Hello everyone, I'm Maziar Mivechi and today I will present a study called Study of Measures to Design Asphalt Mixes with High Percentages of Recycled Asphalt Pavement and Recycled Asphalt Shingles. This presentation is provided for the first annual virtual symposium of Transportation Infrastructure Innovations for Durability and Resilience. Beside natural resources, recycled materials, additives, and recycling agents have been used in new roads to improve pavement sustainability while reduce the pavement cost. Using these materials, as well as virgin binder, aggregate, and volumetric properties will affect the performance of asphalt pavements. Previous studies have found that increasing RAP and RAS content, lowering asphalt content, and stiffening the binder grade will improve the rotting performance but decrease the cracking resistance. However, most of these findings were based on laboratory-based mix designs instead of mixes designed specifically for paving jobs. This study provided a parametric analysis on both rotting and cracking performance of 261 mixes designed by contractors in Washington State to identify the significant parameters affecting city index and rot depth values. This table shows the distribution of the mixes used in this study based on their construction season, nominal maximum aggregate size, target binder PG, and amount of recycled materials. The mixes having both RAP and RAS material are labeled as RAP-RAS. The mixes with RAP material and binder replacement ratio between 20% and 40% are labeled as high RAP, and mixes with RAP material and binder replacement ratio between 0% and 20% are labeled as low RAP. All the 261 mixes were used for rot depth analysis, but only 69 mixes were used for analyzing the city index value, which are the mixes designed in 2019 and 2020 construction season. A stepwise statistical analysis was conducted to identify the significant parameters based on the resulted p-value. This table shows the finalized parameters and their p-values, which are all lower than 0.02. Material passing number 30 sieve, binder content, design air void, and amount of recycled material are all the significant parameters affecting the city index value. Keeping the material passing number 30 sieve lower than 17%, increasing the binder content, shifting the design air void from 4% to 3.5%, and lowering the amount of recycled material will all improve the cracking performance of the road. It should be noted that using a softer virgin binder or recycling agent does not seem to be effective to offset the excess RAP-RAS stiffness in the mix. Asphalt content of half-inch and 3/8-inch mixes, target binder high PG, virgin binder low PG, sand equivalent, and fine aggregate angularity parameters are significant parameters affecting the rot depth values. Decreasing the binder content for both half-inch and 3/8-inch mixes, increasing the target binder high PG, lowering the virgin binder low PG, and increasing the sand equivalent and FAA parameters will all reduce the rot depth of the road. Compaction temperature and the amount of recycled material are also two important parameters affecting the rot depth values. Compaction temperature is selected based on the virgin binder stiffness. Based on figure A, increasing the virgin binder stiffness will result in lower rot depth of the road. This is true for RAP-RAS and high RAP mixes, low RAP mixes, and no RAP mixes. Increasing the amount of recycled material will also reduce the rot depth value. The only exception is for the RAP-RAS mixes in this study. This is because of using recycling agents which may only work effectively for the RAP binder or virgin binders. This study identified the significant parameters affecting the cracking index and rot depth values. Besides, it was seen that low RAP mixes exhibited worse cracking performance than the non-RAP mixes, which may need the binder blending test for low RAP mixes also. Using the recycling agents did not improve the cracking resistance of the mixtures. In addition, the use of a rejuvenator may compromise the rotting resistance of asphalt mixtures with RAS. These findings are all based on mixtures designed by contractors for road pavement. The field performance of these mixes will require future study. Additionally, measures that can effectively increase the cracking performance of high wrap or wrap ras mixes are needed.